What's up, calculus students? Mr. Messer coming at you. Rates homework. Yo, this homework could take a long time if I explain everything. But for you, I want you to try at least three problems on your own and then come back and check the answers, okay? What are the three problems I expect you to do that I want you to try? Well, the first problem, which we actually did in class, try to do it on your own, some different types of questions, A, B, C, D, than maybe what you've seen. This second problem, Janet's shoveling snow. Do this on your own. See how you do. Like if you don't understand part C, whatever, that's not important. It's more about the other parts that are important. If you could skip any question, skip the no calculator question. It's a good question to remind you about how you can find an accumulation or take an antiderivative when it's possible to take antiderivatives and find C, knowing how to use it. Great. But for your test, we're talking about calculators. So do the fish problem. Do those problems, okay? Come check your answers. I'm going to do all the problems with a calculator first. I will finish up with a no calculator question last, as it is least important for preparation for your test, okay? And let's get into showing how what we're doing here is just like what we did last unit, but we have to do a little bit of work to get there, because the key to these problems is that you don't just get one velocity, you're given two velocities. And the velocities come at you in terms of rates. They say, here's a rate. Now they're going to try to trick you because they're going to say, oh, rate equals F. And you're used to F being like a normal equation, but pay attention to the wording of the problems. Rates are derivatives. They are velocities. If you take an antiderivative of a rate, you're going to get an equation of a total. But usually you won't be able to take an antiderivative. So what we want to do is accumulate your rate, and you'll get a displacement of a total. This is so important. If you sum up like feet per hour over an interval of hours, you'll get feet. If you accumulate y's per x over an interval of x's, you get y's. This is like a derivative. This is like a velocity, okay? So understand what you have. All right. Here's what we discovered we have multiple things going on. We have a rate in, we have a rate out. It's kind of easy to understand what a total is going to be if you have things going on, stuff coming in, stuff going out of whatever our situation, whether it's a tank or it's like birds in a nest. You have an initial amount. You have a total amount coming in. You have a total amount going out that you'll have to subtract, and a lot of people understand that. Now, we are going to use the letter P for the total. We're going to use P of 0 being an initial amount. The total in, well, if I'm given a rate in, I need to accumulate my rate in. And when my cursor comes back, I'm going to do that. Accumulate my rate in. Hold on, I got to get the phone. All right. Accumulate your rate in to get a total in. Accumulate your rate out, you get a total out. But watch what can happen when I take the derivative of the antiderivatives are going to kind of go away. Like the integrals are going to go away. I realize that rate in minus rate out, if I have two velocities, one coming in, one going out, combining them and subtracting them gives you one velocity. Which means we actually, understanding what we learned last unit, we can understand that if we have the derivative of P, if we have the derivative, and we know how the original thing is changing, we can accumulate the derivative to figure out how much we change. So instead of thinking about as having two velocities, we combine them so it's one velocity, and all of a sudden we have another expression for total, the initial amount just plus the accumulation of your derivative. This combines that, which means you got options, which sometimes sucks for you kids because you guys hate having options. You'd rather do it the same way every time. But understanding this helps you graph one velocity instead of multiple velocities, see the graph of your derivative, see when it's positive and negative, accumulate your derivative to figure out how much we're increasing or decreasing. All that stuff is repeat from last unit. Okay. If I wanted to, I have my first derivative sign analysis, but it's a combination of my two derivatives, my ins and my outs. So we're cool with a derivative tells us if an original amount is increasing or decreasing. Accumulate your derivative to figure out how much we're increasing or decreasing. Now notice, E and L, they're already derivatives. I don't take the derivative of E and L. It's just my rate in minus my rate out. But if I wanted to figure out how my rate of change is changing, if I wanted to figure out whether my rate is increasing or decreasing, don't forget about your second derivative sign analysis, which tells you about your first derivative increasing or decreasing. P double prime would be E prime minus L prime, or your rate in's derivative minus your rate out's derivative. That's a second derivative. Like since E is already a derivative, since L is already a derivative, since they're already rates, if you take the derivative of them, it's like taking the derivative of a velocity, you get an acceleration. Now, just remember like position, velocity, acceleration. Position's usually in feet, velocity's usually in like feet per second or feet per hour or something like that. Acceleration's feet per second or feet per second squared. This is going to be the same as, I'll pause in just a second, a position's derivative, and a position's second derivative. All right. Now, how do we do this like in a calculator? How can we get everything? There's like lots of different ways, but here's what I'm going to recommend. First of all, read the question carefully. And also like read some of the question parts correctly, because like what we want to do is probably answer all of these questions with as little work as possible. We're not going to do the same thing every time, but it might be helpful to have the same setup every time. Now, what do I mean by a setup? We need to understand the dynamics going on in the problem. We did this in class. We have a rate in. This is my rate in. It's in cubic feet per hour. That makes sense. It's a velocity. It's a day. Okay. Good luck. It's in cubic feet per hour. That's a velocity, like feet per seconds, velocity, first derivative. Cool. Then we have a rate out. Cubic feet per hour. This is my derivative out. Don't be confused by the letters that they give you. It's a capital R. You think of it as like a position or like an antiderivative even. It's not. It's a derivative. And we have an initial amount of 30. Cool. Recommendations. Always, if you got multiple velocities going on, have them in your y equals, okay? And we'll talk about how you can use it without even graphing it. You don't have to graph it, but you can if you want to. Or you should if you have to. Here is my rate in. Here is my rate out. Oh, classic. Cool. I'm not graphing anything yet. I got to have an understanding that my total is my initial amount plus my total in, accumulate my rate in, subtract your total out, accumulate your rate out. which means the derivative incorporating both of those velocities, ins and outs, just subtract the out from the in, p primes r minus d. We're going to come into y3, and we are going to graph y1 minus y2. We're going to graph 0. I'm going to adjust my window so that it's over my interval 0 to 8. Again, you should be doing this yourself. I'm going to zoom fit just this one time so that I can see all of the things kind of interplaying so you can understand why what we see makes sense. Here is the rate at which water is being added. Here's the rate at which it's being removed. I'm going to pause real quick. Notice the rate at which it's being removed is bigger than the rate at which it's being added. Think about that. If that's happening, the total amount should be decreasing. Then the rate at which it's being added is bigger than the rate that's being removed. Think about that. Adding quicker than removing. We should be increasing. Well, guess what? Your derivative, overall P prime, E minus L, kind of works with that. If L or D is bigger than R, then we're going to be decreasing. The derivative's negative. When they equal each other, we're neither increasing nor decreasing. The derivative is 0. When we are increasing more than we are decreasing, then the derivative is going to be positive. Boom. You kind of see that in action, okay? R equaling D, important, but really just showing you, you don't really need to see the graph of R minus D. You could just look at the graph of the velocity overall of your population. So I'm going to go back to zoom fit, and I can see overall, I was decreasing because rate out was bigger than rate in. Then we're equal. Then we're increasing because rate in is bigger than rate out. Great. You have this in your calculator. You make sure maybe like somewhere you list off that I put y1 here and y2 here, and this was y3. It's not something we want to see necessarily in your work. We want to see R and D. You could designate y1 as R and y2 as D and y3 as R minus D. And I can't like not knock you for that. But what we find is students don't put this and just use y1, y2, y3 in their work, and then we can't accept it. You have to establish the connection if you want to use y1, y2, y3. All right, now, this will give us our total. Part A says how many cubic feet of rainwater flow into the pipe. Yo, we just want the total in. If you remember, we have an initial amount, we have a total in, and then we subtract a total out. We just want, for part A, the total in. This is very important. A lot of students make mistakes on this. They think we're asking for a total amount. No, they just want the total in. We just need to accumulate our rate in. Now, watch how I can do this in my calculator really quickly. I already know that y1 is the rate in. I can math 9, accumulate from 0 to 8, my rate in. Wrong button. Alpha F4. Or vars y vars. I keep doing it. This is accumulating my rate in. This is telling me the total in, 76.57. This is a total. The total is like a position. It will be cubic feet. Do I need units? Not necessarily right now, but in the future we will. So just keep in mind, position, velocity, acceleration, feet per second squared. Part B. Again, let's try not to do like a full sign analysis and lots of different positions and stuff like that when we don't want to or don't have to. Let's try to do the least amount of work, but when we get to the part where we need to do a sign analysis, like we'll be ready for it, okay? And we're set up to be ready to do that if we need to. But part B is the amount of water in the pipe increasing or decreasing at 3 hours. Guys, this is key. At 3, what is going on? What is our derivative? Is it positive? Is it negative? Will it be showing me an increasing or decreasing total amount? So this is the key, like a derivative increasing or decreasing, R versus D. Now, they don't ask you for how quickly. So here's all the different ways you can answer this. You can look at the derivative, which you already have graphed. Trace 3. Boom. You could say P prime, as long as you establish what P prime is equal to, R minus D. P prime is negative 0.313, which means the total is decreasing. This is a velocity value by 0.313 feet per hour. Right? It's a rate of change. Feet per hour, it's a velocity, it's a derivative. Remember when we first interpreted derivatives? The derivatives are like an amount that the original function is increasing or decreasing, y's per x. Well, now it's like y's are feet, x's are hours. That's one way we could do it. We could just say P prime is negative. I don't care about the value. They didn't ask you for the value. Since P prime is negative, P is decreasing. Let's say you had the graph of all of them. And you look at 1, 2, 3, you could say, I should have zoomed out a little bit, my total in, or my rate in, is bigger than my rate out. It's another way to do it. Go to trace, go to 3. Let's see where we're at. This is the rate in, which is 5.08. Here's the rate out. If you go up and down, we can see it's 5.4. You can see your D of 3 is bigger than your R of 3. Your rate out's bigger than your rate in. So your total is decreasing. Yo, just showing you like lots of different forms of the answers. Don't put all 3 of them down. Put one of them down. Either find your specific value when needed to. You don't have to. So you can just say like the derivative is negative. Or you could compare the 2 different rates if you want to. Let's move on. Again, I haven't done a full sign analysis yet, though I do see the derivative, which does help me. Okay, and this is why we needed to see the derivative. For both part B and for part C, total is a min. Okay, first, we start with our statement. You must have your statement. P is going to be a min when P prime equals 0 or an endpoint. Or through an analysis of your derivative, seeing that your derivative is negative until some a value, then positive after the a value, your total's decreasing, then increasing. You're asked for just the time. Yo, this could be the easiest question ever. You want to do it easy. We don't do the blind, do this every single time it works, which we did last unit, which is fine. But now let's be a little bit more like directed at our work. Let's not just do the same thing every time. Let's see what we have and then adjust and adapt so we can make it as easy as possible. You know, P prime is negative from 0 to A. P prime is positive from A to 8. T equals A must be the min. Done. You know that. It has to be the min. You don't have to check endpoints. You only have one candidate. This has to be the min. I didn't even find it, and I know it has to be the min. I don't even know what the value is yet, but I know it has to be the min. Now I'm going to do it the other way as well, just so that you guys are comfortable with the other way. But let's find that intersection with 0 when R and D equal each other, and A is 3.2716584. That's the easy way to do it. Like, you don't even have to find amounts because you know it has to be the min. But let's say you do it the candidates test way. Let's do it the candidates test way. Well, we already know P of 0 is 30. We have not found anything else. So we just have to do all of our work. Let's find P of A, which equals 30 plus, I'm going to just have things combined, 0 to A of P prime. And let's find P of 8, which is P of A if I wanted to, or it's P of 0. You guys did such a good job showing your work. So just keep it up. Make sure you have the derivative. Make sure you're accumulating the correct thing. A lot of you used V. That's fine. A lot of you use X prime. Great. I'd prefer you use like X prime, P prime, accumulate a derivative. And let's do it. I need to store this. If you haven't started storing, make sure you store. It just makes life so much easier. You have your initial amount plus, again, you could have this separated into an integral of y1 and an integral of y2, or you can just accumulate p prime, which is y3. And again, just showing you how you could separate that out and get the same answer. If you separate y1 and y2, so you have a total in from accumulating your rate in, and then a total out from accumulating your rate out, you're going to get the same answer. This is the minimum value. Again, it's just a repeat. I probably would do it the easy way. 27.964. It's a position. It's F. It's X. It's feet, cubic feet, not cubic feet per hour. It's a velocity, not cubic feet per hour squared. That's an acceleration. And then I would take that value and add the accumulation from A to 8 of my derivative, which is y3. Or have it separate. Or have it separate just to show you. You could have this be an accumulation from 0 to A of R minus an accumulation from 0 to A of D. All right, so if you do the candidates test way, boom, you list off your 3 candidates. You say, here are where my candidates come from. Here's my min by my candidates test. But again, you have to state where your candidates come from. Candidates test is worth nothing unless you state where your candidates come from. D, the pipe can hold 50 cubic feet of water before overflowing. For greater than 8 times, water continues to flow in and out of the pipe at the given rates. So the rates are going to hold. I'm just going to expand my window. Write but do not solve an equation involving one or more integrals that gives the time W when the pipe begins to overflow. Now, this is where things get a little bit tricky, and when we learn next lesson, we're going to be more comfortable with this. I overflow when my total amount is 50, okay? Well, I want to figure out when my total amount will be 50. Well, again, you start with an initial amount and you accumulate your derivative. Again, it could be with an R and a D separately or together as a P prime. And like it could be P prime of T dt. But then it's like, well, how do I find this? Well, it's like, we got to figure out when my accumulation equals 20, we got to figure out when having a W in my integral, it's like, what is the time when this will equal 20 so that overall it equals 50? You could either have it like this, or you could say, hey, what time, what ending time will the accumulation of my derivative be 20, displace 20, so that we get to the maximum level before we overflow of 50. Having a variable in an integral is confusing to a lot of students, but it involves w, it could involve t. You're going to be able to see how you could solve for w later in this class, how you can take an antiderivative, plug in w, plug in 0, and then have an equation you could solve. All right, we did it all. We're good. Next question. Snow on the driveway. There's no snow on the driveway to start. Boom, that's important. No snow. Initial position. Our C value, if we could take it to antiderivative, 0. This is time. This is an amount. This is also cubic feet per hour. They try to trick you guys. Rate modeled by F, cubic feet per hour. So many students read the letter and then assume they know, oh, this must be a position. This is an F. This is in feet. No. F is a derivative. F is a rate. F is a rate in. What the heck? Why are they doing that? Why can't they tell me it's an F prime? Sorry, this is how they get you. Paying attention to details is an important part of the AP Calculus exam. They'll give you F, and F's a derivative. Jerks. But it's okay. We got it. This is my rate in. This is my velocity in. G is my velocity out. Again, it's a derivative. That means the derivative is going to be F minus G. Now, this is why it's like nice to have like P and P prime listed so that you're like, okay, there we go. There's my derivative. There's my little tick mark. So I'm ready, like, here's my derivative. Now, what's different about this question is that my rate out is not just one equation. It changes, okay? You don't look at all three at the same time. You look at one at a time depending on your window. All right, well, what I would do if I wanted to is just, it's not necessary, especially with all of the different Y's, all the different rate outs, but I would definitely graph the rate in. This is my velocity in, 7t e to the cos t. And if I wanted to, I could graph the separate rates out. But maybe label them, that way you like pay attention to which one's which. F is y1. I'm not graphing 0 because if you accumulate 0, you're going to get 0. I hope we understand that. We're going to say 125 is y2. We're going to say 108 is y3. Now, you could look at rate in minus rate out, F minus G. If they're going to ask you about a rate of change, whether things are increasing or decreasing, we could look at y1 minus y2. This is only going to be from 6 to 7 times. And then y1 minus y3 is only going to be from 7 to 9, those times. If you wanted to have these, you could. But I'm going to show you like you don't have to unless you want to do a sign analysis. I'm not going to graph it. I'm just going to have everything in there just to accumulate easier. How many cubic feet of snow have accumulated? So again, we think about our total, which is our initial amount plus our total in this case, accumulate the rate in, minus the total out, or the accumulation of my derivative, where my derivative is F minus G. This and this are the same. But be careful, F minus G changes from 6 to 7, this would be F minus G. From 7 to 9, this is F minus G. Cool. P prime equals F minus G. Be careful. We just want our total in. So this is where having it separated is important. Here's my initial amount. This is like the total snow in. This is the total snow removed. We just want total snow that's accumulated. We haven't even started shoveling yet. We're not removing, so we just want this. So that's Y1. I'm going to accumulate from 0 to 6, Y1, which is F. So I got an integral from earlier. Y1 has changed. This is why I love using Y1 so much, because we can just grab it instead of having to type in things over and over again. We get 142. Again, this is a total in, so this is in cubic feet, not cubic feet per hour. That's a derivative. That's a velocity. Part B, find the rate of change of the volume of the snow at 8 a.m. Okay, so I want to figure out how P is changing at 8. I want to find P prime at 8. Well, remember, we need F minus 108 at 8. So I need F of 8 minus 108. Now watch the different ways you could find this. You could go and look at the graph of Y1 minus Y3 from 7 to 9. I don't even know if these are all positive and negative values. I assume they're negative values. Janet's going hard and is removing snow, but let's see. At 8, that's nice. I got negative 59.5829. That's the derivative. It's asking you the rate of change. So negative 59, we want the negative value, 0.582 cubic feet per hour. Again, this is in cubic feet per hour. This is in cubic feet per hour. This is a derivative. It's the first derivative. So if you want to interpret this at t equals 8, snow is decreasing by 59.582 cubic feet per hour. Y's per x. One way. Here's another way. You know that Y5 is this P prime. You know Y4 is this P prime. Watch what you can do in the home screen. You can go Y5 with parentheses 8, and it plugs in 8 into Y5 for you. Boom. Or you could plug in 8 into F, whether it's using Y1 or just plugging in 8. Sometimes we lose this when we use Y1 and Y2. Plug in 8 into F. This is your rate in minus your rate out. Boom. See all the different ways I can get this number. And again, we can also do Y1 at 8 minus Y3. At 8, if we plug in 8, it won't make a difference. Plug in 8 or just minus Y3. That's how you get your number. That's your derivative. See, let H represent the amount of snow in cubic feet that Janice has removed from the driveway at T hours after midnight. Express H as a piecewise function. This is the one that everybody's going to get worried about. But let me just tell you what I would care about. Can you tell me the total amount that's been removed? Could you tell me that? Hopefully you're like, yeah, sure, Mr. Messner. We can just worry about the total out. That's accumulating G. But my G changes, so I need to accumulate different G's at different times. So the total removed is 0 from 0 to 6, and 125 from 6 to 7, and then 108 from 7 to 9. Can you get this? Can you understand this? If you understand that, then you really understand this question. That's the total amount removed. It's like, and now here's the kicker, guys. If your velocity is consistent, if your rate of change is consistent, 125 cubic feet per hour over the course of 1 hour, you know this is just 125. Type it into your calculator. See, 125 accumulated from 6 to 7 is just 125. What is this? 108 cubic feet per hour over 2 hours. Plug this into your calculator. It's 108 times 2. It's 216. See, when your rate of change is consistent, this is easy. Cubic feet per hour over hours. We only need the accumulation function when our rate is changing. And it's hard to splice it up into a lot of cubic feet per hours over tiny little amounts of hours and add those up. So there's kind of what I would be looking for. Now, if you want a piecewise function for total out, I'll call it big O of t. Well, you are going to not remove any snow, total out. This is, again, essentially like taking antiderivatives, right? Can we take the antiderivatives of 0, of 125, and 108? Take the antiderivatives of G, and what would we get? Well, we'd get some sort of constant, but really, we're not removing any snow, and there's no snow on the ground. So we're going to start we'd start with C, but we know that C is 0. Cool. This would be 125T. This would be 108T. This is kind of the idea behind the piecewise function. 0 from 0 to 6, but then 125 feet per hour over the course of the next 1 hour. Now, it's tricky, and again, I don't want to worry you about, I need to be able to plug in 6 and get 0, and plug in 7 and to get 125. I adjust this by putting a t minus 6, so that plug in 6, you get 0, plug in 7. It's almost like we have this, and we take the antiderivative and plug in t, and take the antiderivative and plug in 6. But that's tricky. So don't worry about it. If you're stressing out about this, don't stress about it. This is what I care about. You understanding that. That's what's important. And then at 7, we've already removed 125 feet, and then we start removing at 108 feet per hour. Again, not super important. What's important is, can you tell me the total removed? Can you split this up into multiple integrals to get the total out? Because part D is how much snow is in the driveway. Now, again, there's going to be multiple ways to do this, which freaks students out. We want the total amount at time 9. You can accumulate P prime, since there's no initial amount, from 0 to 9. But you can't just do this so easily. You got to go from 0 to 6, because P prime is just F. And then you got to go from 6 to 7, where P prime is F minus 125. And then you got to go from 7 to 9, where P prime is F minus 108. That's going to be tricky to plug into your calculator. You have the whole... This is just Y1. This is Y4. This is Y5. You could do that. I'll do that in a second. But what would I do? just keep it easy and keep it separate. Go back to kind of my original idea where the total amount at time 9 equals my initial amount plus my total in is accumulating my rate in minus my total out, which we just talked about here. You can have the total out being 0, 125, 108. You already know what this value is. It's 125 plus 216. You're going to get the same way, either understanding how P prime changes or just keeping ins and outs as separate. Let's get the answer. Let's accumulate Y1 from 0 to 9. Now notice it's 0 to 9 because it's like snow fell over the 9 hours. Let's get the total out. 6 to 7 of 125. This is Y2. Or you can just type in 125. 125. Boom. Let's get 7 to 9 of Y3. 216. Let's add those together. This is the total out. Obviously, I'm not accumulating 0 because I'm going to get 0. Total in minus total out. 26.334. Cubic feet, it's a total, it's a position, it's an F. Let's get that value the different way. Math 9, 0 to 6 of P prime, which is just F minus 0, plus six to 7 of P prime, which is Y4, which is F minus 125, plus 7 to 9. Again, I'm not subtracting, I'm just adding because it's going to be a negative displacement. Plus 7 to 9. Snow falls at a lesser rate. Janet's still removing of Y5. And I'm going to take that value of 133 and decrease it by a significant amount. And I'm going to get that 26.334. Got to understand what's going on. Different ways to do things freak out students. Just get the right answer. Get the right answer. You didn't have to figure out maxes or mins, thankfully. I'll come back to the no calculator problem and do the fish problem. Do this fish problem, call it a day. Fish enter a lake at a rate modeled by the function E. Fish leave the lake at a rate modeled function by L. I don't know how many fish started in the lake. Let's just assume there's 0. Honestly, probably all the questions will involve like not finding the total amount, rather total in and total out. All right, so if I wanted to understand my situation, I have my initial amount plus I have my total in minus my total out. My derivative is going to be E minus L consistently, which is nice. And that means that my total amount can also be an accumulation of my derivative P prime. Which incorporates both the E and the L at the same time. Where we have 0 to start, don't forget the initial amount's important because the accumulation of P prime tells us how much we're increasing and decreasing. How many fish enter the lake? Yo, that's just going to be this part, the total in part. All right, so I'm thinking of, I'm just going to show you what to do. Y1. Average number of fish that leave the lake per hour. It's asking you for the average L. You got to remember, add up your L's, divide by your interval. So this will probably be Y2. Okay, we're going to need to do an analysis of P prime. We're going to have to graph E minus L. So I'm going to look at E minus L over the interval 0 to 8. I'm going to do a sign analysis. Oh, part D is great question. Part D is the rate of change increasing or decreasing? Yo, this is the idea of a second derivative is going to tell you if your first derivative is increasing or decreasing, which means you're going to need E prime minus L prime. All right, we kind of know what to do. You just got to do it. Clear off everything. I mean, you might as well second plus 7, 1 to it. E L E minus L. Since I am going to be doing a sign analysis of my derivative, again, if you wanted to, you could graph all three, but I really just want the third one. But it's nice to see all three. We're going from 0 to 8 for the greatest. Most of the times we're going 0 to 5. Let's remember how we graphed it. The first one's going to be the rate in. Second one's going to be the rate out. Third one's going to be rate in minus rate out, overall velocity. Here's my rate in. These values should all be positive. If you have a negative rate in, it doesn't make sense. Here's my rate out. So we should be gaining fish. We should stop gaining fish, and then we should be losing fish because of rate out being greater than rate in, and that's what the derivative shows you. Okay, so we kind of make sense. The intersection here is the 0 of my derivative when rate in equals rate out. Just going to change it just so we're looking at the derivative. Go back to zoom fit so we see a nicer just derivative. This is the overall derivative. This is the velocity of the overall situation, incorporating the two velocities at the same time, rate in minus rate out. All right, part A, easy. How many fish entered? We just want to accumulate E. Total in is an accumulation of a rate in, if that's what you're given, a rate in. So math 9, 0 to 5 of Y1. Because I graphed Y1, don't forget dx. You get 153 to the nearest whole number is 153. Now, why did I give us a whole nearest whole number? Because we're talking about a total amount of fish. If you wanted to help yourself out, P prime, P double prime, X, V, A, F prime, F double prime, fish per hour, fish per hour squared, right? It makes sense, this stuff, like a position, a velocity, an acceleration. F prime, F double prime. I've accumulated a rate. I get a total. This is not fish per hour, just fish. Total fish. Now, the next one is the average fish that leave per hour. So when I accumulate L from 0 to 5 and divide it by 5 hours, I get an average L. I get an average fish per hour. It's kind of hard to understand why this is fish per hour, but we kind of talked about how it's like it's an average rate of change of the derivative. Gives you the average antiderivative. It's the other way around. Don't worry about it. Average of something, accumulate something, divided by the total, you get the average of that thing. So if I change this to Y2, which is the rate out, and divide it by 5, this is average L, average fish per hour that have left. All right, now part C, my friend, part C, the derivative sign analysis, which we've already done. Yo, can we answer this question easily? Look at your derivative. The answer is yes. Do you need a candidates test? No. Can you do a candidates test? Sure. Sure, do a candidates test. But you don't have to. P prime is positive until A, then negative till 8, which means my total amount is increasing, then decreasing. A's got to be the max. We need to start to get better at understanding, like, do we really only have one candidate? Don't waste your time. What do they ask you? At what time? There it is. The max P at T equals A, since the derivative, make sure you have it written down somewhere that P prime is E minus L. You got to write it down or it doesn't count. Since P prime is positive from 0 to A, and then P prime is negative from A to 8. You're done. Let's say you love the candidates test. Here's what you do. P is a max when P prime, really you should say changes sign, because sometimes you'll have zeros, and we'll talk about that in the next two things. P prime changes sign or an endpoint. Ooh, senior meetings.
Don't rush.
Cool. P of 0, 0. P of A would equal 0 plus the accumulation of your derivative or your accumulations of E minus L's. And then P of 8 equals P of A plus your accumulation from A to 8. I feel like she says that because she does want to talk to you.
There's some award.
Oh, that's great. 0 to, oh, geez, forgot to find the intersection. Don't forget to find and store A. Because, like, I have the answer A, but I never even wrote it down. A equals 6.20356444, which is fun. It's like you can write down the answer without even having it. You just know it's got to be there. Store that. All right, here we go. Math 9, 0 to A of P prime, which I put as Y3. You should probably, like, have that written down. This was my Y1. If you want to use it, you can. This is my Y2. If you want to use it, you can. And this is my Y3. If you want to use Y3, you can, but I prefer you use P prime. It's safer. That's going to be my max for sure. I know that. Now, since there's really no initial amount, you could just go 0 to 8 instead of splitting it up. But if you wanted to split it up, you could have taken P of A and then added your integral from A to 8. And we should understand how, like, there's multiple ways to get the right answer. You could accumulate over your entire interval as a shortcut, or split it up like a lot of you do. Many of you are probably still up here and accumulating P prime and writing down the numbers here and utilizing the numbers here plus here to get that. That's fine. But, like, we should be okay maybe skipping that need to have this full sign analysis done with all of the numbers. You can have it. Some of you are very much in the graphing part, which is fine. There's that 135 accumulation added to 0 gets you A. And then many of you are still in the graphing part, which is fine, but might take a little longer. It's nice to see it, honestly, you see it accumulate. Subtract 54 fish. You gained 135 fish, you lost 54 fish. This makes sense. Where's your max right here? Is the rate of change increasing or decreasing at t equals 5? Is the rate of change increasing or decreasing? That means I need the second derivative. I need the derivative of p prime at 5. Remember, p prime is what we graphed as y3. Here, this is p prime. I wish I could. Can you get rid of the shading? I bet you this will regraph it. This is p prime. This is the derivative. We want the derivative of a derivative. We want to find the slope of the y3 graph. We want to find the slope of the slope. We want to find the derivative of your derivative. What you see as a derivative, find the derivative of the derivative. This is the derivative of p prime. This is p double prime at 5. It's negative 10.722. It's an acceleration. An acceleration. We graph the velocity. The derivative of velocity is an acceleration. This is fish per hour, or fish per hour squared. Which means the rate is decreasing because the second derivative is negative. Fish per hour. Fish per hour squared. Okay? All right. Yo, if you can do those 3 problems, we're good. Like it's a good start. You should have done them by yourself, gotten the answers without me talking. I'm going to do the last 2 problems, but again, this is like extra. This problem is very much like the Janet remove snow problem because the rate out changes. Sometimes the rate in changes too, guys. Like you got to be ready for that. Then, this is the no calculator question, which just requires you to remember, like, can you take antiderivatives? Can you get position equations? We can't take antiderivatives of any of these equations besides maybe this because it's just tricky. We don't want to do it. All right? Now, this is nice. They're giving you the rate in graph and the rate out graph. And they're making it piecewise so you can see it. Probably I'm going to go ahead and say this is the rate in. These are my rates out. My rate out changes, so I need to look at the rate outs for specific intervals. I'm going to graph this at y1. I'll put 250 at y2. We're going to only look at y2 from 0 to 3. I'm going to put 2000 as y3. We'll only look at y3 from 3 to 7. I can go straight to understanding my derivative is f minus g, but my derivative, which I'll put in y4, which is f minus 250, I will only look at from 0 to 3, those times. And then in y5, I'll look at my derivative, which is f minus 2000, but I'm only going to look at f minus 2000 from 3 minus 7. Now, it's important to understand they have the rates graphed. What they don't have is the combination of the rates graphed. This is like when we graphed y1, y2, and y3, which is y1 minus y2. They are graphing y1 and y2. This is y1. This is the rate in. This is the separate y2s. This is y2. This is rate y3. So like we could actually create this exact same graph if we wanted to, just in a piecewise manner. I'd look from 0 to 3 and then from 3 to 7. They're telling you when the rate out and the rate in equal each other. So this is important. Like they're kind of helping you out. We could find those values easily if we wanted to. But let's just get into the questions and make sure we understand what we're doing. How many gallons of water enter the tank? This is the idea of my total equals my initial amount. Oh, I didn't even pay attention to that. I have an initial amount plus my total in minus my total out. Careful with G. I just want the total in. So I'm just going to accumulate my rate in. It's F. You think of it as being an antiderivative, as an original equation, but that's actually a rate. Tricky AP test. Time intervals in which the amount of water in the tank is decreasing. I'm going to show you how you can get this answer doing what we like to do, which is graph the derivative. But you kind of have everything graphed. They did give you the intersections. When rate out is bigger than rate in, you're decreasing, right? If rate out is bigger than rate in, then your derivative is going to be negative. Like if G is bigger than F, F minus G will be negative. Your total is going to be decreasing. This is something that should just make sense. We can actually answer this question right now from 0 to 1.617. I'll go back and show you the other way to find it. And then from 3 to 5.076. Again, I'll go back and we'll graph our derivative, rate in minus rate out, over my interval to find those same values. When is the water in the tank the greatest? Honestly, probably the best thing to do in this case is the candidates test. Because we're going to have 1, 2, 3, 4, 5 total candidates, which sucks. But whatever, we'll just get locked in and we'll just go from there. So we need a P prime sign analysis from 0 to 3. We need a P prime sign and displacement analysis from 3 to 7. Did you pick your job?
Yeah.
What'd you pick?
Combat engineer. No problem.
Good.
I went to MEPS. Yeah, that's where I've been past couple days.
And everything good?
So stuff from my freshman year, whenever I was in.
Okay. Let's get everything out of here. Reset. Let's graph our Y1. Our rate in. Have that ready to roll. If we have to use it multiple times, it's helpful that it's here. Let's graph our rate out from 0 to 3 and from 3 to 7. Let's graph our rate in minus our rate out for my first interval, which you're going to see the combination of what they show. And then let's graph our rate in minus our rate out for our second interval. Let's not graph anything yet until we need to. Let's just stop. What was the question? Number 1, total water in. Accumulate your rate in from 0 to 7. I've already entered that. Bam. $8,263. I did not incorporate the initial amount. I did not incorporate anything else. All right. I already answered this question it's going to help us to understand C. So let's just see it using the derivative versus using the separated derivatives. Let's see it using P prime, where we're going to look at the different derivatives on the different intervals. We should see exactly what we want to see. So I want to hide everything, though we would be able to see exactly this graph if we wanted to. Except for y1 minus y2, I'm going to adjust my interval to be from 0 to 3. 0 to 3, I'm going to y prime. Now, here's what I expect to see. Rate out bigger than rate in. My derivative should be negative until 1.617, and then positive after that. Zoom fit. My derivative is negative until 1.617, and then it's positive until 3. Great. Second calc, I forgot to graph y equals 0. Oops. What's going on? Second calc, intersect, enter, enter, enter. Bam. Now I got to hold on to that value. I'm going to store that as A. So new A, we can see my derivative was negative until A and then positive. Now let's graph y5 from 3 to 7. What do we expect to see from 3 to 7 is, again, a negative derivative, then a positive derivative. Because rate out is bigger than rate in, then rate in is bigger than rate out. So it's kind of like a repeat of this, only we're going to have a B. So 3 to 7, let's zoom fit this. And I should see a negative derivative. The intersection should be at 5.076, then a positive derivative. That's exactly what I see. Second calc intersect, bam, 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 bam. There's that 0.76. And I'm going to call that B. And again, the derivative is negative then positive. So A is that 1.617 value. B is the 5.076. When is the amount of water in the tank decreasing? Like there it is, 0 to A and then 3 to B. They kind of helped you by giving you the intersections. They didn't have to do that. Now, greatest. This is where sometimes the candidates test sucks big time. I said it. You have one endpoint, two endpoints, three endpoints. 0 and 3 and 7 are endpoints. It's like where intervals change. A and B. 1, 2, 3, 4, 5 different points that you have to find. Wouldn't it be nicer if we could eliminate some? Yo, P is going to be a max when P prime changes sign from positive to negatives or an endpoint. The fact that I don't say P prime equals 0, that I'm more specific about P prime changing sign from positives to negatives being a location of a max, knows that mins can't be location of maxes. This is a local min. This is a local min. This is a min. This is a min. It's not the overall min, but it's a local min. Because I don't want to check those points because I know they can't be the maxes. We need to improve our candidate statement so we can do a better job of not having to list all 5 candidates off. Really, my only candidates are 0, 3, and 7. If You said P prime equals 0. Well, you got to find A. You got to find B. Sucks for you, but you can do it. And I'll do it anyways, just in case you do it. P of 0 we know is 5,000. Okay, we already know that. Let's find the accumulation of Y4 from 0 to A. We got to understand my accumulation of Y5 from 3 to 7. So here, P3 is 5,000 plus the integral from 0 to A of P prime, which I use Y4 because it's the correct derivative from 0 to 3. And then P of 7 is going to be P of 3 plus the integral from 3 to 7 of P prime, which is going to be Y5. All right. Home screen. I didn't find B. I don't need to find B. Why am I doing A? Come on, Mr. Messner. We're going from 0 to 3. We are bypassing A. Thank you. Of P prime, that P prime. Again, you could split this up. You could have 0 to 3 of F, and then minus 0 to 3 of 250, which is 750. 5126, 590. Now I know what P of 3 is. I will add the accumulation from 3 to 7 of P prime, but P prime is Y4, Y5 this time. Four five one three 806. We could kind of see that, like right here, like the area between them would show us how much we're losing or gaining. We can kind of see, and we can go back and look at the accumulations. This total accumulation, total out, is less than how much we are coming in. This is going to be a lot in. But then we are going to lose a boatload of water and then just add a little bit of water comparatively. So it makes sense that this is the max. I gain more than I lose, and then I lose more than I gain. Boom. All in max. If, from my limited candidates. If I wanted to, I could also find P of A, and I could find P of B, which I forgot to find, but whatever. P of 3 plus integral from 3 to B of P prime. I might just skip the no calculator problem. I need to be done with this anyways. This is good, grand ambitions, but we gotta move on. All right, what was A? Good. Y4. Or split it up. Yep. P of 3. Plus Y5's accumulation. Oh, I forgot. Yeah. Y position 3 plus the accumulation of Y4 from 3 to B. That displacement. y5. Okay. It might actually be helpful, yeah, to have it listed off as y4, y5. That way they know you're looking at different p primes for different time intervals, incorporating the rate in minus the rate out for the different time intervals, accumulating them differently. You know, it's like p prime from 0 to 3 is different than the p prime from 3 to 7. But you have that listed. You know, this is p prime from 0 to 3. This is p prime from 3 to 7. I don't think you have to have this. I think if you have p prime equals f minus g, and then you just do the right thing without like listing off that you're changing it, it's kind of assumed that if you say f minus g, that you're only looking at the right g at the right time. All right, skip the no calculator problem. It's not going to be on your test. It is something that, you know, is a good problem to do. I'm doing it. I'm doing it. But you skip this. My computer sounds like it's going to take off. Total amount 30 plus total in minus total out. E minus L. What's great about this is actually it becomes an easy question because P prime is E minus L. P prime is 18 minus 3T. That means P can be found not as this, but as like an equation finding C. 18T. I gotta stop Screencastify. It's about to blow up. 18T minus 3 halves T squared plus C. C is 30. Like this is P of 0. Man. Like it sounds like my computer is about to blow up. P of 0 is 30. That's C. You actually have an equation for your overall population or position of birds. You can take your derivative sign analysis. You're going to find at 6, that's when P prime will change signs from positives to negatives. You have expressions to find P, so you actually don't need to find the accumulations really ever. Just look at these positions. Look at P of 0, P of 6, and P of 8, which you'll have to find without a calculator, and I don't want to do that. Some things that you might have to do is how many birds left the house. Well, this is a good one. This is accumulating 2t from 0 to 10. Now, this is the idea of finding the displacement. Take the antiderivative and plug in 10 and 0. And you'll have a plus c, but the plus c will go away. So not hard to do because you can find the antiderivative. It's different from all the other ones. If you skip this one, I'm okay with it. All right, Mr. Messer out. Rates out.